Hey there, curious minds! Ever wondered what quantum computing is all about? Well, today I'm going to break it down for you. Quantum computing is like the superhero of the technology world. While classical computers use bits as the smallest unit of data, quantum computers use qubits. Think of a bit like a switch that can be either on or off. A qubit, on the other hand, can be in both states at once, thanks to the magic of quantum mechanics. This means quantum computers can process a massive amount of information simultaneously. Now let's dive into the 4 key principles of quantum mechanics that make quantum computing possible. First up, superposition. Imagine spinning a coin. While it's in the air, it's both heads and tails at the same time. Similarly, a qubit in superposition can represent both 0 and 1 simultaneously. Next, we have entanglement. This is like having 2 magic dice that always show the same number, no matter how far apart they are. When qubits become entangled, the state of one instantly influences the state of the other. This property is key for the incredible parallel processing power of quantum computers. Third is quantum interference. Quantum particles can behave like waves, and these waves can interfere with each other. By carefully controlling this interference, quantum algorithms can amplify the right answers and cancel out the wrong ones. Lastly, we have quantum tunneling. Imagine a ball rolling up a hill, but instead of stopping and rolling back down, it tunnels through to the other side. Quantum particles can do this, allowing qubits to solve complex problems more efficiently than classical bits. So how does quantum computing work? It all starts with creating and controlling qubits. These qubits are stored in quantum states using various methods like trapped ions or superconductors. Then, quantum gates manipulate these qubits to perform calculations. Finally, the results are measured and decoded into classical data. Now, let's look at some real-world examples. Quantum computing is already making waves in fields like cryptography, where it's used to break traditional encryption methods and create virtually unbreakable codes. In medicine, quantum computers help simulate complex molecules for drug discovery, potentially speeding up the development of new treatments. Even in finance, quantum algorithms optimize trading strategies and manage risk more effectively. And that's a wrap on quantum computing. It's a fascinating field that's still in its early stages but holds immense promise for the future. So keep your curiosity alive, and who knows? Maybe you'll be the one to unlock the next big breakthrough in quantum tech. Thanks for watching, and don't forget to like, share, and subscribe for more amazing insights.